Welcome to Learning with Mr. Neff.
Yes, today, with Learning with Mr. Nev, we are going to learn how to graph two variable inequalities with my top-notch class. I can't say which period for others. So, okay. So, they're, they're working in construction outside. So if you hear random noises, that's what that is. Okay. So, here is the example we have, and I'm going to do my very, very, very best to explain it, okay? You are to graph this, but it means to graph all the solutions, right? So when we say solve, it means show all the solutions, all right? Step one, we're going to make a boundary line. Step two, we're going to pick a test point, and then we're going to shade one way or another above or below the line. So first step here, we are going to write y. Our boundary line is y equals 2x plus 1. So what we're going to do is we're going to have the students sit down and pay good attention as we go over this. So y equals 2x plus 1 is our boundary line. So we're going to graph this first, okay? And then we're going to shade. So it's really two things, graph a boundary line and then shade. So how do I graph y equals 2x plus 1? The slope, alright, so the y-intercept is 1, so I'm going to put a dot at 1, and then what am I going to do? Yeah, that's my slope. Rise 2 over 1. Rise 2 over 1, yep. Back and keep, yeah, alright. So here I see my points, and I could keep going. Now what I'm going to do here is I'm going to draw the boundary line, but I have to distinguish between the greater than and the greater than or equal to. Remember how we did open and closed dots? This would be an open dot. So, but we can't really show an open dot, so what we're going to do is we are going to draw a dotted line. So open dot is really the dotted line here, okay? Yeah. Now, the pen, nope, this is my pen. So, yeah. All right. So here it is. Notice the arrows. Don't forget your arrows. Now, it says y is greater than 2x plus 1. Now, which side do you think I should shade? Like over here? Over here. Above or below the line, right? Right here. I'm thinking over here, okay? So since I have this and I can erase it easily, I'm going to shade over here first, okay? So I think that's the way I'm supposed to shade. So let's pick a test point, though, and see. What is an ordered pair in this area right here? Negative 1, negative 1. That is clearly right not there, okay? What is clearly in this area, not on the line? Negative 3, 1. Yep, right there. Negative 3, 1. I could do a different color. Negative 3, 1. Right there it is. Okay, so we're going to test out to see if that works. All right, negative 3, 1. So 1's the y. Right, is that what you said? Negative 3, 1. So 1's the y. Is 1. Yeah, I could put parentheses on that. 1 is greater than. Is this true? 2 times negative 3 plus 1. What is that? 2 times negative 3. Negative 6 plus 1 is negative 5. In your head, you did that? Or calculator? Calculator? All right. Is that true, though? Is that true? Yes. Therefore, we shaded the right way. All right. Now, just to prove to you that over here are not solutions, somebody pick a point over here. Okay. How about an easy one like 2, 1? Okay. How about 2, 1? Right here's 2, 1. Okay. All right. So let's go ahead and C, if we can't extend this, okay, is, so now I'll put parentheses, 2, 1. All right, is 2, well, is it, what do I want to say? 1 greater than, what do I want? 2 times 2 plus 1. Is this true? Is 1 greater than what? 5. Is that true? No. Oh, nope. I ran out of room on there. No, it's not true. Therefore, we don't shade over here. So that is our solution area over here. Any point in here is a solution, but the points on the line are not the solution. They're just a boundary. Okay? If it was a solid dot, they would be. All right? That's a good learning with Mr. Neff video, I think. Let's sign off now. Everyone say bye-bye.
Bye.
Okay.